So today we're finishing up Pythagorean Theorem, but now we're going to be talking about it in real world context. So we're going to be looking at some word problems, going through. The best way to deal with word problems is just get into them, work a whole bunch of them, so make sure that you understand it. Remember, we're still dealing with Pythagorean Theorem, so we're doing that a squared plus b squared equals c squared. We're going to be using that, and as we go forward, we're going to use it in doing with whatever they're talking about in the word problems. A lot of these are ladder problems, shadow problems, how tall is this building or wall or whatever, that type of problem. So here we go. Finn takes a sheet of paper and cuts from one corner to the opposite corner, making two triangles. If the piece of paper is 17 inches long and 11 inches wide, what is the length of the cut nearest 10? So here, they even gave us a diagram of what they're talking about. So they really kind of made it where it's not that difficult for us. What they've done is they took a piece of paper, they cut it diagonally, and they said, hey, what is that diagonal cut? What is that distance between here? Okay, so what did they give us? They gave us the legs. They're asking us to find the hypotenuse. Remember, the hypotenuse is opposite the right angle. So all we're going to do is we're going to take these numbers, plug them into Pythagorean's theorem. 11 squared plus 17 squared equals c squared. And we're going to just plug these in our calculator, make sure we get them right, and go from there. 21 plus 17 squared, 289 equals c squared. Going to add these two together, and a lot of you guys are just going to do most of this real quick together and not have an issue here. You get 410 equals c squared. Take the square root of both of these, and then you'll have your answer. So the square root of 410, and you get 20.24, but we're going to round to the nearest 10, and that's what we get. All right, so 20.2 should be our answer. 20.2 inches, okay, because label required, you should have that. And I'm going to flip over here to the answer so we don't have to plug that in. 20.2 is our answer. We're good. We can move on to the next problem. All right. Yeah, this is a pretty good one. Latasha climbs an 11-meter tower to ride a straight water slide. The slide is 27 meters. After landing in the splash pool, how far does she walk to get back to the base of the tower nearest 10? What did they give us? Well, they gave us one length. They gave us the hypotenuse, which is the length of the slide. And they want to know, from here to walk back to the ladder, how far is it? So they're asking for the other leg. So we're going to take these numbers, just like before, plug them in. But now, what did they give us? Well, they gave us 11 squared plus b squared equals 27 squared. So solve just like we did at the very first day. So we should already know how to do this. The hard part's plugging it in, getting them in the right spot. 121 plus b squared equals 27 squared, let me find it, 729. Okay, we're going to draw our line and we're going to solve for b. So add the inverse. Crosses out, b squared equals 608. Take the square root, b equals 24.7. It was 6.5. 5 rounds that 6 up to a 7. 24.7 meters walk from here to here. Again, we're just going to look at the answer, so I don't have to go there and plug that in. 24.7, 24.7, we're good to go. All right, look and see if there's anything else in there. Paper, tower, as this is the same thing. Water slide, they just gave you a different one. Okay, so that's really all there is. Oh, here's a ladder is leaning against a vertical wall. The distance from the top of the ladder to the base of the wall is 7 feet. The length of the ladder is 33 feet. What is the distance from the base of the wall to the bottom of the ladder? So here they gave you a diagram, but pay attention to what they gave you up there. They gave you the ladder, they gave you the wall, they want to know the distance from the two, okay? So they gave you the hypotenuse, they gave you the legs. Once you get that, you can do this problem, no problem. All right, we're going to move up, we're going to do one of these other ones. Because now they start getting a little bit harder because they don't give you a diagram. When they don't give you a diagram, you got to be especially careful to plug these in correctly. All right. A 19-foot flagpole casts a shadow. The distance along the ground from the base of the pole to the tip of the shadow. Okay, so guys, I draw this. Okay, a 19-foot flagpole. Here's the flagpole, 19 feet. Okay, casts a shadow. The distance along the ground from the base of the pole to the tip of the shadow is 22 feet. See what I'm doing as I read this? I'm drawing what's happening. Okay? What is the distance from the top of the pole to the tip of the shadow? What is this distance? That's what we want to know. So we were looking for this distance right here. They gave us this one, they gave us this one. We want to know this one. So we're going to substitute it into Pythagorean Theorem. 19 squared plus 22 squared equals c squared. Now, I know that this is a leg, this is a leg, because right here is my right angle. Here is my hypotenuse. Okay? Now I'm just going to do this. 19 squared, 361 plus 484 equals c squared. Add those two together. Get 845 equals c squared. Take the square root of both. So you can take the square root of 845. 29.1 equals c, and this should be feet. 29.1 feet. Now we're going to check the answer here. 29.1 feet, 29.1 feet. When I read this, I'm reading it for content. I'm making sure that I can draw this. I'm not going to try and do this without drawing it because I might make a mistake. A ladder is leaning against a vertical wall. All right. So here I have a wall and I have a ladder leaning against it. Okay? The distance from the base of the wall to the bottom of the ladder is 19 feet. So from here to here is 19. Okay? The length of the ladder is 32. The length of the ladder, 32 feet. What is the distance from the base of the wall, to the top of the ladder? Okay? I'm telling you, I draw this. It makes it so much easier. There's my right angle. What did they give me? They gave me a leg. They gave me the hypotenuse. I need to find the other leg. That's all there is to this. So here we go. Solve it just like we would the others. A squared plus b squared equals c squared. All right? So, I think we did 19 just a second ago, didn't we? Yep. A squared plus 361 equals 32 squared, 1024. Okay. Now I'm going to solve for A. So, draw my line. You could subtract 361 or you could add its inverse. I prefer adding the inverse, just makes more sense to me. Cancels out. A squared equals 663. Take the square root here, get A equals 25.7 feet. That's what you're looking at. All right. 25.7 feet. Again, once you get this plugged in, and once you get this drawn and plugged in, you're gonna have no problem, because we've been doing this for a couple days now, we should understand how to do this. But it's this right here that I think we're gonna have our issue with. Gotta be careful with that, make sure you get the numbers in the right spot, because if you get them in the wrong spot, now you're getting wrong answers, and you're struggling, okay? Okay, so we did a ladder, we did a shadow question, there's another shadow question, another shadow, tower question, yeah, slide, yeah, we're looking good, okay. So that's what there is for this. Be careful when you read through these, watch what's going on. We got one more to look at, and this one's a little bit trickier. All right. Patricia, notice here, they gave us a model here to look at, but you gotta be careful with it. Let's read it and see what's going on with this right here. Patricia leaned a 40-foot ladder against the side of a building. Okay, there's our 40-foot ladder right there. That makes sense, okay? The base of the ladder is 8 feet from the base of the building. Okay, there's the base, it's 8 feet, no problem. The top of the ladder is 16 feet from the top of the building. How tall to the nearest tenth of a foot is the building? Oh, so our ladder doesn't reach all the way to the top of our building here. So we want to know how tall is our building from here to here, and they gave us the distance from here to the top of our ladder. That's what's going on. So what they want to know is the full distance from the very bottom to the very top, but we don't know what the distance is here. So we're missing one of the legs. So we got to find the distance here and then add it to this 16 to find the whole distance of the wall. That's what we're looking for here. Okay, so we're going to find this distance, then add it to that 16 to get the whole distance. So set it up. Same way as we've been doing. So what did they give us? They gave us one leg and the hypotenuse. A squared plus B squared equals C squared. A squared plus 64 equals, what do you should know that? I don't remember. 1600, yeah, I should know that. All right, so we have this, okay? We're gonna solve for A, just like we have been. So add the inverse, cancels out, bring down A squared equals take the square root, you get A equals 1336. You get 39.2 feet, I believe it's feet. Yeah, feet. But this is not your answer. This is not your answer. You still got to add 16 to this, right? Because this, right here, this number just gets us the distance from here to here, but we want the distance from here all the way to here, and that includes an extra 16 feet on there. So we got to add 16 feet to this to get a good answer. So 39.2 plus 16 gets me 55.2 feet. That's my answer. So A does equal 39.2 feet, but the distance of the wall, the height of the wall, is 55.2 feet. So that's what you're looking at here. So here, answer, 55.2 feet. There we go. Be careful with that one. Watch that, watch what they're trying to do to you, okay? Because they're trying to get you to mess up and give them this 39.2 feet when really they want this, okay? That's what that word problem's doing to you. All right, so let's take a look and see what else we got inside here in this one. A right triangle and two of its side lengths are shown in the diagram. That's straightforward. Which measurement is closest to the value of W? So now, which one's the closest to the value of W? So they give you a whole bunch there. One leg, one hypotenuse, find the other leg. That's what that is. Which measurement could represent the side lengths of a right triangle? Which one forms a right triangle? That's what they're asking here. We did this when we did models. So when we did models, we did this. So one side, a squared plus b squared, is going to equal c squared. So you're going to put those two together to make sure that it equals that. So you're going to go through there. Remember how to do that. We've done this before, so that's nothing new. Same one. Same here. Okay, let's look at this. This is just like we did the first one. Let's do another one of these just to make sure that you understand how to do this, and then we'll call it good. All right. Winston leaned a 61-foot ladder against the side of the building. There's our ladder, 61 feet. The base of the ladder is 23 feet from the base of the building. 23, that's a leg. That's our hypotenuse, that's our leg. The top of the ladder is 20 feet from the top of the building. That's the extra that we got to go. How tall to the nearest tenth of a foot is the building? All right, exactly like the last one we just did. Different numbers, but it's the same problem. A squared plus b squared equals c squared. All right, so 23 squared, 23 squared, a squared plus 529 equals 61 squared, 3721, draw your line, 529, okay, cancels that out, brings down a squared equals 3,192. Take the square root of both sides to get rid of that, because this undoes that. Okay, bring down your a equals square root 56.5. Again, I rounded here, but that's not my answer. Watch that. That's just the distance from here to here. We still got another 20 feet to add on to it. So what we really have is 76.5, I think it's feet, right? Yeah, foot. Feet, 76.5 feet. They're trying to get you to plug that in when it should be this. 76.5. Here's our answer, 76.5. Guys, if you have any problems with this, you let me know. It's not too bad, especially after we've been doing this part now for over a week. So if you run into any issues with how the word problem reads, what you're actually looking for, contact me, let me know.